Norm, how do I optimize the fractionator operating pressure?
That's a really good question. Unfortunately, most people simply run their fractionators at some design pressure, or some people simply run at a pressure consistent with the ability to condense the overhead vapors. The problem is there are several competing factors to optimize the tower operating pressure. Certainly, as you lower the pressure, the relative volatility between the propane and the butane, the light and heavy components, increases. So you might think, from the point of view of relative volatility, reducing tower pressure would be a good thing. And it may be a good thing. But it also may cause higher vapor velocities, which could result in excessive amounts of entrainment. That is jet flood. As you increase the condenser heat transfer rate and lower the tower pressure and the vapor velocities increases, so does the entrainment of droplets of liquid from the tray below to the tray above. And that will take the heavier components, the butane, and push them up into the overhead product, which is bad. However, since most of the trays in a modern refinery are perforated tray decks and not bubble cap trays, these trays have a tendency to leak or weep or dump. And it could be that as one raises the tower pressure too much to suppress entrainment, to improve tray efficiency, to get away from jet flood, that the resulting lower vapor velocities will reduce the pressure drop of the vapor flowing through the tray, and especially if the trays are not particularly level, the trays are now going to leak. And again, if they're not level, they will leak at the low point. The vapor will go through the high point of the tray. You're then going to promote vapor-liquid channeling, which then destroys tray efficiency. So to summarize, lowering the pressure is good in that it stops the trays from leaking and it promotes higher relative volatility. But on the other hand, lowering the tower pressure may be bad because it promotes high vapor velocities and jet flood and entrainment. How then should one know what pressure to use? It's very simple. Look at the temperature difference between T1, the tower top temperature, and T2, the tower bottoms temperature. That tower pressure at a fixed reflux rate that maximizes the tower temperature difference between T1 and T2 is the optimum tower pressure. Now, if you're meeting all your product specs, why bother? Well, to save energy. Because lowering the tower pressure, or perhaps raising the tower pressure depending upon the circumstances, may allow you to get better fractionation than you need. And that will then permit you to lower the reflux rate, which will in turn reduce the reboiler duty, which will result in energy savings. You don't know until you try by experimentation.